One place we'll often meet a restricted domain is when we're looking at the quotient of two functions. Why? Well, in general, what do we need in order to be in the domain of a quotient function? Right, well, we need to be able to figure out f, and then we also need to be able to figure out the value of g, but a little bit more than that, right? After we figure out the value of f and figure out the value of g, what are we going to do? Division. What goes wrong with division? We aren't allowed to divide by 0. So we need to have g of x not be 0. Sometimes that's not hard. Sometimes that doesn't cause an issue. Maybe we have some function that's never 0. So for example, if our g of x is the absolute value of x plus 1, right, his range, well, the absolute value of x is always a positive number or 0. So the absolute value of x plus 1 is always greater than or equal to 1. So in this case, g of x is never 0. But for most functions, well, they're going to be 0 somewhere. What do we do in that case? Sometimes when we write the formula for f over g of x, we need to explicitly restrict the domain. This especially happens a lot when f and g are polynomial functions. Let's see an example. Suppose that f and g are these two polynomials, and we want to write f divided by g of x. Well, that's going to be this polynomial divided by this polynomial. Let's do that division. X goes into 2x squared, 2x times. 2x times 1 is 2x. We need the total to be negative 3x. So that means we'll need negative 5x. X times what is negative 5x? X times negative 5. Negative 5 times 1 is negative 5. We need the total constant to be negative 5, so we have no remainder. We might want to say that f divided by g of x is 2x minus 5. But this is a polynomial function. Its domain is all real numbers. Why doesn't that work? Well, the domain of this quotient only includes points where g of x is not 0. So this only includes points where x plus 1 is not 0. This is actually a legitimate answer to this question, but it is much nicer to simplify this restriction. Right, subtracting 1 from both sides, we get x is not negative 1. The quotient of these two functions is the function given by 2x minus 5, but only defined where x is not negative 1. I'm going to give you one of these to try now. Let f of x be 2x cubed minus 7x squared plus 2x plus 3. G of x equals x minus 3. Write the quotient function f over g of x. Pause the video and try this now. All right, well, we'll do the division first. X minus 3 will divide into 2x cubed. X into 2x cubed is 2x squared. 2x squared times negative 3 is negative 6x squared. I need my x squared term to be negative 7x squared. Negative 7 minus negative 6, I'll need a negative 1x squared. X times what gives me negative 1x squared? X times negative x gives me negative 1x squared. Negative x times negative 3, that'll be positive 3x. I need my x term to be 2x. 2x minus 3x, that'll give me negative x. X times what is negative x? X times negative 1 is negative x. Negative 1 times negative 3 is positive 3. I need my constant term to be 3. That's what I've got. I don't have a remainder. So my quotient, f over g of x, well, it'll be 2x squared minus x minus 1. But that's not all, right? What am I missing? G of x is not allowed to be 0. So x minus 3 is not allowed to be 0. Add 3 to both sides here. I get x is not 3. This is the restriction on my domain.